The world is expanding, and so is the construction sector. The construction industry has started to endorse IBS as a method of improving construction quality and performance, decreasing occupational safety and health risks, mitigating issues for skilled workers, and reducing reliance on manual foreign labor, and ultimately reducing the total cost of infrastructure in construction projects. However, there is a recognition that the trend towards industrialization of building industry is a worldwide movement rather than a local or isolated initiative. The definition and category should expand and reflect global perspective and understanding. Offsite, prefabrication, offsite construction, modern technique of constructing building, offsite production, offsite manufacture, and pre-assembly must all be defined and classified. It provides a new perspective and broadens one's knowledge of the IBS idea as a whole. This research was carried out to find the overview of the use of Industrialized Building System IBS for SK Bandar Behrang 2020 PERA, which helped to give a better understanding of the application of IBS in Malaysia. The construction of the school started in 2011 and was completed in 2012. The completion of the construction of this building took a short time due to the IBS system used on the walls of the building. The following is the objective of the study. First, to explore the concept of IBS use for SK Bandar Behrang. Second, to identify the feature and suitability of IBS components. Third, to observe the fabrication and installation procedure applied in SK Bandar Behrang. Fourth, to discover the schedule of modular components of IBS. And fifth, to determine IBS co-calculation for SK Bandar Behrang building.
Industrial Building System. The IBS technique was utilized by Sekolah Kebangsaan Bandar Behrang to construct the wall in each of the school blocks. The block used for this report is a classroom block consisting of 4 levels, each with floor classroom. The following are the examples of the components that are typically involved in an IBS structure installation plan. Features of IBS system. Number 1. Better quality. Factory control conditions and the use of cutting-edge manufacturing process make it much easier to obtain the appropriate dimension, forms, colors, and the texture of precast concrete in precast construction. Number 2. Design freedom. Custom-made solution and the intelligent use of the industrialized manufacturing method can result in a diversity of expression and distinctive buildings. Number 3. Economic advantage. The pace of construction might enable business save even more costs. While foundation and site works are being complete, component production can proceed. They can then be easily assembled on a job site. Number 4. Manpower saving. Especially important for construction companies that are experiencing a labor crisis due to the rapidly decreasing pool of skilled workers obtainable from conventional sources. Number 5. Neater and safer sites. The usage of precast concrete and the other fabricated components during construction will assist in reducing wastage of material. The removal of formwork, scaffolding, and wet thread allows the construction site to be cleaner, neater, and more structured. IBS Building Plan of Sekolah Kebangsaan Bandar Behrang, Tanjung Malim, Perak. The 4-story block has 16 classrooms where there are toilets and stair facilities on each side of the floor. Construction of the entire school project took a year, starting in 2011 and complete in 2012 due to the utilization of the industrialized building system. The following is classroom block plan that consisting of 4 levels.
The next one is application of IBS system. The IBS component that we use in the school is precast concrete wall. The suitability of this precast concrete wall is it consists of fire resistance that will provide safety to the building occupants. The walls does not need any maintenance, but the connections, sealants and accessories need to be maintained regularly. There are 2 types of connection details. The first one is bolt connection and the second one is the cast in situ connection. There are 7 steps of fabrication process for precast concrete wall. The first one is the workers need to assemble the mold depends on the size needed. They need to clean the mold to prevent any debris or dust. The rebars and pre-testing strands need to be fixed and did a final inspection before casting. Next, the workers can start to concreting the mold, then curing, and lastly, demolding the precast concrete wall. Next is the installation process. The first process is setting out, setting a reference line and offset line for the area to put the concrete wall. Next is mobilization. After inspecting the area's alignment and verticality, lift the concrete wall to its specified spot using crane. And the third one is the connection. The panels can be connected to other panels by using bolt connection or cast in situ connection.
Schedule modular component. In this study, the modular component used was precast concrete wall. Precast concrete walls are built to meet structural requirements for strength, safety, and other features. Various width is used in the project according to specific area with thickness of 200 mm. This schedule shows for about the 3D view, plan, quantity, and the system of the modular component. For the wall 1 with the 7500 mm width and in 25 quantity. For the wall 2, 5400 mm width and 8 quantity. Wall 3, 4500 mm width and 16 in quantity. For wall 4, 8700 mm width and 16 quantity. For wall 5, 3000 mm width and 8 quantity. Wall 6, 4500 mm width and 8 quantity. And lastly, for wall 7 with 900 mm width and 16 in quantity.
As we can see, these are the IBS core calculation table. For the part 1, the structural systems. There are 4 levels in this building and all of it have the same floor area. But because of the IBS factor is 0, it makes the total of IBS score for part 1 is 0%. Next, in part 2, wall systems. Both external and internal wall are using precast concrete wall panels. The IBS factor is 1 for both types, so the IBS score for part 2 is 20%. Next, in part 3, that shows about other simplified construction solutions. The data about coverage of IBS use had been inserted and the total of IBS score in part 3 is 19%. Then after we total the summation of IBS score in these 3 parts, the final total IBS score is 39%. In conclusion, the application of the industrialized building system IBS in the residential and non-residential buildings is getting proper recognition from year to year. In this case study, it was done at Sekolah Rendah Bandar Behrang 2020 in Perak, and the component of IBS that have been installed was precast concrete wall panel with 200 mm thickness concrete block. The IBS scoring calculation shows that in structural systems, there is 0% of IBS score, but in wall systems, there is 20% of IBS score together with other simplified construction solutions that make 19%. The total of IBS score in this building is 39%. It can be increased by using some precast components in structural system. A higher of IBS score in a building is a reflection of a reduction of site labor, lower wastage, less site materials, better quality, safer construction site, faster project completion as well as total construction costs.